Microsoft and Kongsberg Digital are transforming heavy asset industries with AI technology. By keeping humans at the center of technological innovation, we integrate AI into every aspect of our work, aiming to empower individuals to make impactful decisions and have complete control over their work. Our cutting-edge AI capabilities bring the use of LLM and AI to heavy asset industries through three foundational pillars. Data. It starts with connecting different data points into our contextualization layer, which then creates a 3D representation of your environment. Trust. You can then decide which LLM and AI to use for your workflows and which data points to utilize. We are choosing Microsoft Azure OpenAI service to provide trusted access to the OpenAI platform. With the Azure OpenAI service, developers can access the OpenAI platform through the Azure portal and use a variety of AI models and tools to develop and deploy intelligent applications. Control. Our built-in AI capabilities bring industry-leading constraints to help you control, govern, and trust AI. As users take action in the surface, a secure digital record of operations is generated. This record is crucial in enabling smarter, safer, and greener ways of working. Watch as we showcase our AI-powered industrial work surface and how it helps diffuse a potential incident on an onshore hydrogen facility in Germany. Our story begins with the detection of something that needs further investigation. Sandeep, an analyst from the Chennai Remote Operations Support Team, is on the case. He follows the notification to a trend chart. To get full overview, he briefly assesses the situation in 3D through the digital twin. With the aid of our Asset Copilot, Sandeep quickly and efficiently finds previous causes of the same event. Sandeep was confident in the Asset Copilot's response due to the reasoning engine's data transparency protocols. He sees what permits the sensor is associated with and which work orders that are related. Let's open the portal and look at what's going on behind the scenes. This is the Copilot Sandeep asked for a summary. In this case, its logic is powered by GPT-4 and Azure OpenAI integrated with the Azure platform. You can easily pick or choose one or multiple LLMs that fit your purpose. You can even use different language and different AI models for different workflows. Once you have configured your AI, you deploy it to the workflows you select through the self-service portal. The portal lets you deploy which tools, plugins, and sources the AI will fetch information from. By accessing this layer, you have complete transparency and full self-service capability. Through the Azure-powered search function, Sandeep finds the two similar events. He files a service request to a specialist for closer investigation. We follow the service request 348 kilometers inland to Bangalore, where we meet Archana. She starts her investigation by asking the Asset Copilot about the sensor. Tell me about 41LT652. The Asset Copilot returns relevant information about the sensor. It's a level transmitter. Note that the information is color-coded light yellow, indicating that the response is generated by using authority data. This is retrieval augmented generation in action. You are not asking the AI to respond based on its world knowledge. You're asking the Asset Copilot to retrieve all the relevant data, reason over it, and combine it into a coherent response that matches your intent. Show me the real-time trend for this. The Asset Copilot summarizes the recent real-time values. By looking at the technical documents, Archana notices there's a sensor close by that could complement the situational understanding. Tell me about 41LT651. Compare 652 and 651. This time the result is depicted in amber. The comparison between the two sensors does not exist in the data. It is produced by the AI by combining, comparing, and summarizing. Archana knows this information has to be used with caution, but finds the comparison relevant nonetheless. Both sensors are reading similar trends. This is not a sensor error. Arcana notes that the issue requires immediate attention as it impacts production. Find the cause and establish a plan to ensure continued safe production. She initiates an operator round via the operations cockpit, providing the on-site operations team with all relevant history and suggested causes to be checked, including the option to remotely support and guide the on-site team for maximum efficiency and speed to resolution. She proceeds by using AI search to find relevant information about the compressor. What type of compressor is K4101? AI search returns summarized information with high relevance and provides a shortcut to the source. The compressor is a reciprocating compressor. This time, the specialist asks a more abstract question. What are the causes of packing wear or leakage for the compressor in question? As you can see, AI search retains context and understands intent. What is a recommendation for a gradual change in rod drop? Based on learnings from the past, the AI search returns relevant experiences, among them an analysis of a similar situation and a recommendation for the next step. Arcana compiles and hands over her findings. They show up as a work item for Wolfgang, an on-site engineer on the other side of the world. Wolfgang locates the equipment while the analyst and the specialist follow the process in real time. Wolfgang asks the multimodal AI to reason over a picture, a piece of the equipment. He then asks for an analysis of a close-up of the machinery shaft. The corrosion is clearly visible on the surface. The engineer resolves the issue, and with the assistance of AI, Wolfgang fills out the template to raise a work request notification in order for the planners to schedule the maintenance work. With the power of AI, we've moved an anomaly from the hands of an analyst to a diagnosis in the hands of a specialist to a solution in the hands of an engineer. Kongsberg Digital and Microsoft, shaping the future of work.